I'm Lisa Aultman-Hall. I'm the Transportation Professor at the University of Vermont's Transportation Research Center, and I'm also the Associate Director of the National Center for Sustainable Transportation here at UC Davis Institute for Transportation Studies. And today I want to talk about some concepts that are important for considering the efficiency in different modes of passenger transportation. I want to help you answer the question, are airplanes really more efficient? In addition to wanting to introduce some concepts about our air transportation system, which often get neglected in the typical transportation classes in our colleges and universities, I'd like to talk about some of the units of measure that are important to these efficiency questions. Things like the energy required per passenger mile, and also vehicle occupancy, how many people are in those trains, cars, airplanes, or buses, and how that's important for considering the relative sustainability of different modes of transportation. I'd like to help you reflect on just how sustainable your transportation portfolio is over a year and how we can change the system to make it better for everyone. In 2013-2014, I was privileged to be the leader of a research team that assessed overnight travel of a group of 628 people. They were volunteers from across the nation. 62 of them were from California. And what we did was we tracked all of their overnight travel for a whole year. And what this map is showing is all the states that the 62 Californians traveled to. The circles are sized to be proportional to the number of overnights spent by those 62 people in each of the states. And you can see that just that limited number of people over 1 year traveled to so many places. Not just across the nation, but across the globe. 62 Californians visited so many places across the globe. If you look at the right-hand side of the slide, what you see is this was not just an average random sample. This was a convenient sample of quite highly educated people, people with higher incomes, who travel much more than the average American. But still, to think of this global reach of overnight travel in just a year for 62 Californians is quite incredible. The Vermonters, too, had a global reach in their travel, 229 of them traveling to almost every continent on Earth. What has really facilitated this extensive globe-wide travel in 2019 and the last couple of decades has been our extensive air transportation system. We have grown used to, many of us have grown used to, actually relying on this air transportation system for so much intercity travel. And it's time to think about how, as planners and engineers, we change that system, make it more sustainable as we move into the future. So how much do we fly? There are 15 airports in the United States that have over 20 million passengers a year. The Federal Aviation Administration, who runs our airport control towers, handles 43,000 or more flights per day at 19,000 or more airports. Now, most of these airports are private, but nearly 5,000 of them are actually public airports. 2.6 million passengers a day fly in our American transportation air system. The airport system is huge. In 2019, globally, we're expecting there to be 40 million commercial flights. Now, if you look up numbers like this and you start looking into the air transportation system, I'd encourage you to be careful. Are you talking about just commercial aviation? Are you including the very extensive general aviation, all those small private planes or those large private planes? Don't forget about all the freight planes, freight transport, the extensive number of military flights that we have in our American system, and then the helicopter transportation that's used in many cities, but also for other purposes in the United States. 28.5% of the U.S. greenhouse gases are from transportation, and at first glance, it appears as though air travel is a seemingly small part of that greenhouse gas. Only 9% of those transportation emissions from transportation. But I think it's really a much more complicated story than that, because air transportation is growing. We also really are not sure how we're going to bring a low-carbon portfolio of sustainable fuels into the air transportation industry. And although there's talk about electric airplanes, those are really only apply for very short travel distances, not the global reach that we've become used to in our current air system. What we see on the graph here is between 2002 and 2016, both domestic and international travel by air growing in the United States, international now being more miles than the domestic and increasing at a greater rate. Even though America has experienced quite a substantial growth rate in air travel, other parts of the world have an even bigger growth rate projected and are experiencing those growth rates in recent years. And what this really tells us is that in terms of greenhouse gases and climate change, we do need to be thinking about how to move towards a more sustainable air transportation system globe-wide. So that gets us back to this question of about whether airplanes really are more efficient. And so what we see on this graph is from 1980 to 2012 from US DOT statistics. We see the BTUs per passenger mile. And this is this important unit I was talking about on slide 1. How much energy, in this case British thermal units, does it take to move one passenger 1 mile? If one person moves 1 mile, that's 1 passenger mile. If 2 people move 1 mile, that's 2 passenger miles. If 10 people move 10 miles, that's 100 passenger miles. So that's really the outcome we're interested in for our input of energy. How many passenger miles are we able to move? And what we see on this graph is that over this time frame, rail has remained the clear winner. It takes the least amount of energy to move a passenger mile in the rail system. We also see that bus transit has decreased in efficiency. It's now taking more energy to move a passenger mile in our buses. Now, that's not because the buses have been getting less good or less efficient. It's because we have fewer people on those buses. Transit ridership has been going down. And that gets towards the second variable I was talking about paying attention to for efficiency in the passenger transportation system, which is vehicle occupancy. How many people are in each vehicle compared to the capacity of that vehicle? We see in the blue line the relative efficiency for cars over this time period, and we see that that's been going down slightly. Our cars have been getting better. In fact, some of our cars have been getting much better than this blue line suggests, but we still have a large number of large trucks and SUVs in our passenger transportation system that are meaning that line is not going down as fast as we would like to. The real successful story on this graph is actually that green line, which is the air transportation system. Since 1980, and in fact since decades before that, the energy efficiency of our air travel has been getting better and better and better. And there are many reasons for that. The airplanes are getting better, the design of not just the airplane itself, but the engines, the way the airlines operate the airplanes in their ground operations, takeoff and landing, have improved. And also they're filling the airplanes up, so they're getting that increased vehicle occupancy, which is turning into decreased BTUs per passenger mile. So that gets us back to the question, at what trip distance should I fly instead of drive to minimize sky carbon emissions? If we're just looking at the average efficiency, which that graph showed us, we would say, well, maybe we should always fly. But most of us know that for efficiency, we're not going to fly across town, that most of the energy gets used on takeoff. And so there is sort of a certain length of trip before it's really worthwhile, efficiency-wise, to fly. And everybody's really after this magic bullet, this magic answer, if you will. Well, at what trip length should I fly instead of drive? But that's quite a complicated question. People in the survey I referred to from 2013-2014, where we tracked people for a whole year, did a whole bunch of traveling by surface modes, shown in blue here, and by air modes, shown in green. We can see that most of the overnight trips that these people took were under 250 miles, and that once you get over 250 miles, people start using airplanes. Once you get over 500 miles in one-way trip length, people are using airplanes for the majority of these trips. What we really don't know, because there's so much variation and so many factors to pay attention to, is whether or not this pattern of what people actually did is the most efficient system state that we could have. We really don't have a clear answer to whether or not shifting around these trips to different modes might mean overall less energy was used. A lot of times we hear people say, well, one flight from LA to New York across the coast, that's more carbon emissions per person than annually all the driving of a single car. We don't really know this exactly for sure. There's so many factors that go into converting this, including the vehicle occupancy, but also accounting for the emissions from airplanes beyond carbon dioxide, and also accounting for emissions at altitude. But it seems to be roughly consistent on most people's estimates that one flight can be the order of magnitude of a lot of driving in a car. And in fact, that one flight may be the equivalent or more of the greenhouse gas emissions in a third world country for a single person. So this is concerning, and we have to take a deeper look at, exactly, are airplanes really more efficient? And the answer is there's no real easy answer. It depends. It depends on a lot of things. It depends on that aircraft and engine design we've talked about. Exactly what type of airplane are you going to be on when you travel from A to B? It also depends on that flight length. The more miles you go, obviously, the more energy that's needed. So these two factors together are quite complicated, and we need to take a little bit closer look at the relative importance of the flight length versus the aircraft and engine design. So what we see here is every blue bar is a different type of plane that's used for short haul, medium haul, and long haul in the commercial airline sector in the United States. And what we see on the x-axis is the number of miles per gallon that these airplanes are able to get on average for each of these length trips. And so we see for short trips, we get fewer miles per gallon, pure seat miles per gallon in this case. And on long trips, we get less seat miles per gallon, that there's less efficiency on those very long trips. And so that's because we have to take off with more fuel. But the important part about this graph is there's actually more variation between aircraft types in the design of that aircraft than there is between how long a trip you're taking. For the most part, the efficiency of that trip in terms of passenger miles per gallon is really a factor of the type of airplane you're on, something that we as individual travelers can't really control. So when we go back to this graph and we look at over the whole air travel sector, that it's slightly more efficient than driving, we have to ask ourselves, well, what other factors are going on? What else is at play here that we should be thinking about if we're trying as an individual to travel more sustainably, or if we're trying as professional planners and engineers to build a more sustainable system? Well, a lot of those things are things that we sometimes forget about. There's not just the energy that goes into flying the airplane from your origin airport to your destination airport, but there's also the energy used to run the airport and all the ground operations that are required at that airport. There's also your own airport access and egress. When you travel from home to a destination from the left to the right-hand side of the screen, when you do it on the green line on the road, you just go from that origin to that destination if you do it by car in an automobile on the road. If you choose to travel by air, you have to travel to an airport. You may have to travel to an intermediary airport, to a final destination, and then finally use some surface mode to travel to your ultimate destination. So it's not just as simple as taking an average airline efficiency and the distance between your origin and destination and saying whether driving or flying is more efficient. There's the ground transportation that's associated with air travel, and then there's also all those extra air miles you travel because you have to travel within the airport system that we have available to us. So there's stops, there's routing, there's circling, things that you can't necessarily have control over. There's also the speed your airplane goes, the atmospheric and weather conditions. It's certainly more efficient usually to travel east in America than to travel west. The Federal Aviation Administration is implementing and has been implementing over the last few years a system called NextGen, a system of advanced computers that will make the routing and the takeoffs and landings more efficient in our overall transportation system, and that's going to improve that average efficiency, but it's also not something that we as travelers particularly have control over. Finally, I would say the most important thing to worry about in terms of comparing different modes of travel and which is more efficient is the vehicle occupancy. How many people are in all of the vehicles? Are they filled to capacity? And in 2017, commercial aircraft were flying at an average load of 82% in the US, an increase from prior years. But what about how many people are in the car? This graph is showing us the efficiency in terms of that BTU per passenger mile, the energy per passenger mile, for cars, buses, and for a Boeing 737. And what we see is that on the right-hand side is the efficiency per passenger mile if there's one person in the vehicle. And on the left-hand side, if the vehicle's full. So if we just look at the top bar, what we see is that we get a much more efficient trip in terms of BTU per passenger mile if we have 5 people in the car compared to 1 person. If we have a more efficient car, say like a Toyota Prius, that's more efficient per passenger mile for 1 passenger and for 5 passengers. And if we skip down to the bottom line, what we see is the white bar, which is the average occupancy of a Boeing 737 in the US, and the left-hand side of the bar, a full capacity, 160 passengers. And we see that indeed, the energy per person mile for a full aircraft is better than the energy per passenger mile for a car with 1 or even 2 passengers in it. And that's what we colloquially hear mentioned over and over again in our society. Airplanes are so much more efficient. It's because we're talking about a full airplane compared to an empty car. The thing we never talk about on a day-to-day basis is how efficient a coach bus can be. So if we look at the left-hand side of the bar number 3, we see that a coach bus beats even a full Prius. Interestingly enough, if we look at the right-hand side of bars 3 and 4, what we see is that they go way, 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 way off scale. And in fact, that makes sense. An empty bus or an empty airplane is going to be very inefficient in terms of energy per passenger mile. But what about if we think about these efficiencies differently? The distances that cars and buses and airplanes travel in our transportation system tend to be different. What if we think about efficiency per trip? An average car trip and the average bus trip and the average airplane trip from that year-long survey that we did in 2013-14 is actually plotted here. And what we see is the efficiency range, depending on the vehicle occupancy, for each trip of these average lengths. And so what we see is that when you account for trip length, the energy used per passenger mile for a person trip is much higher on the airplane than compared to either of the options by car. And of course, that efficiency on a bus depends very much on how many other people are on that bus with you. And so that bears out when we look at people's travel patterns over a year. What we see here on the left-hand side is the number of trips those 628 people in our study took over the course of a year. Many of those trips were regional, or interregional, some continental. But if we actually tally up the miles of those trips, many, many more of the miles were on the continental trips or the global trips, the international intercontinental trips. And so we have to start asking ourselves, where are the miles? And the miles tend to be in airplane travel. And airplane travel is facilitating much of our intercity travel in today's current society. So in terms of sustainability, we need to be thinking about, well, what are the benefits and costs that we get from this intercity travel? There's a lot of environmental costs, the emissions, something we've been talking about in this mini lecture, but also other things, the use of land, noise, and there's financial cost, there's physical health cost, time that we sink into this travel. But what are the benefits of that intercity travel? What are we getting for those both societal and personal costs? We're getting a lot of social interaction, we're getting opportunities and experience, in some cases economic development, employment, leisure, break from routine, a lot of important things. So all of a sudden, thinking about the sustainability of our air system becomes even more complicated than just thinking about the efficiency per passenger mile. So are airplanes really more efficient? They're not, no. At what trip distance should you fly instead of driving to minimize your carbon emissions? That's not even really an important question. You need to be looking at the length of your trips. On a personal level, use trip distance as your criteria. The efficiency of the vehicles, the planes, the trains, the cars, is a very little difference compared to the difference by trip length and the difference of vehicle occupancy. On the system level, as professional planners and engineers, as we're looking to optimize the system and increase sustainability, we need to be seeking policies that maximize vehicle occupancy and the mobility options that we have available to us. I want to thank the US DOT for the UTC grants that supported this research and acknowledge the ideas and data analysis of Chester Harvey that were so important for this work.